In this section, DSMA 1, Numbers, we are going to learn about place values, rounding numbers, number sets, and simplifying expressions or working with order of operations. Before working with place values, let's review what numbers that we can use to make larger values. So these are called digits. Place them at the top of the screen here. And the values we can use 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are 10 digits in here that we can use to create larger values. Now let's take a look about these place values. So notice, first of all, the decimal point, which separates the whole number part from the decimal section. So on the left-hand side, you can see that we start with ones in this first place value, tens, hundreds. This 2 is in the thousands position. Then you have 10,000s, 100,000s, millions, and you keep going to the left and extending out into the billions if you'd like. However, when you go to the right of the decimal, notice we change and start with tenths. There's a THS on that very end. Hundredths, thousandths, and 10,000ths. We need to know these place values so that when we discuss rounding, you will know what place value we are rounding to. Very important. This problem is asking us to determine the place value for the digit 5 in the whole number, 5140 or 5140, which we will learn how to write that here in just a moment. So I wrote the number down, 5140, and I'm going to identify each of the place values. So this 0 is in the ones position. This 4 is in the tens position. The 1 is in the hundreds position. And this 5 is in the thousands position. So the answer to this question is determine the place value of the digit 5. That will give you thousands. Determine the place value of the digit 5 in the whole number. So they gave us a really large number and they want us to find the place value for that digit 5 again. So let's go through each, starting from the far right, each of the place values. This is ones, tens, hundreds, thousands, 10,000s, 100,000s. So the 5 is located in the 100,000s. Notice there's a hyphen between the word hundred and thousands. So this would allow us to choose this last answer for our final response. As mentioned on slide 3, you will learn how to write numbers into words. For this one here, we have write the number 1,570,000 in words. This is a multiple choice question, so it's a little easier for us to pick out the right answer. However, in order to write this into words, we need to understand our periods. We know about the place value. Now we're going to look at the periods. So if I were to say whatever the next 3 digits would, or 2 digits in front of the 1, those 3 digits together is consistent with a period. So this is in the millions position, the million. The next 3 here are in the thousand period. Remember, this is called a period. And they occur in sets of 3. So the way we would say this number is to start from left to right, say the number in the first 3 positions there as normal, This will just be the number 1. And then follow it by the period. So what we have is 1 followed by the period, million. There's a comma, hesitation, so place the comma. The next 3 numbers you would say as 570. So 570 followed by the period. The period in here is the 1,000. And since the remainder of the numbers are zeros, we can stop right there. So again, you're going to use the comma to separate the period. You'll say the number as you normally would that is occurring in that period, followed by the labeling of the period. So 1,000,000, 570,000. And this one here, it looks like we are going to choose which one? 1,570,000 looks like the second one here. All right, let's take a look at those other answers just to see what they would look like. 1,570,000. So this would look like 1,570,000. So there's no 1,000 period identified. So those are all 0. And that becomes 570. So that's what that one would look like. The third one, it says 1,570 million. So that one doesn't make sense in its own because we know that the million period occurs first before the 1,000 period. So that's in reverse order. So that one would not work. And then we have 1,570. So then this would be 1, 570. So you can see that those other answers would not make sense. As we learned on the previous slide, we will state the numeric value in each period first, followed by the labeling of the period, comma, next number, followed by the period, and so forth. So in this case here, we have 96, 293, 647. So in this first part, remember working left to right, this is in the millions period. And the next 3 is in the thousands. If we go further out to the left, we'll hit billion and trillion as far as period goes. All right, so the first thing we're going to do is take a look at the 96. All right, and we're going to rewrite that. 90-6, which is in the million position, followed by a comma. So 96 million. The next 3 numbers, you're going to say it just the way you see it, 293. (290-3). And these 3 digits are in the thousand period, followed by another comma. And then we state the last 3 digits. And the last 3 digits would be 647. See if I can get my pen to work. There we go. All right, so when I look at the possible selections on there, 96,293,647, it would look like the first one. Option A would be my choice. Again, if we look at those other selections just to see what they look like, we have 96 billion. All right, so 96 billion. It doesn't mention any million periods, so that would be all zeros. 293,000, so 293,000, 647. So that is what the second selection would look like. The third selection uses the same period twice, million and million, so that would not make sense. And then let's take a look at the next one. 96 billion again. 293 million. It doesn't mention the 1,000 period, so that would be all zeros, followed by the 647. So you can see those last three options would not work for us. This slide is about rounding whole numbers. And what we have are some examples here. The numbers that are circled on the left-hand side are the place value. Now, this place value happens to be the tens position. These are the numbers that are circled. The number to the right is what will determine whether the numbers that are circled will stay the same or increases by 1. So take a look at the number 12. The number 12, 1 is in the tens position. The number 2, we ask ourselves, is the number to the right of the circled number 5 or larger? If the answer is yes, we will add 1 to the tens position. If the answer is no, then we change to a 0. All right, so in this case here, the number 12, what it's really asking you is the number 12 closer to 10 or is it closer to 20? We're looking at the tens position. So it rounds to 10. The next number, 114, we went around to the nearest tens position. That's that second number 1 here. We look to the right, the number is a 4. It's less than 5. So that means the 1 in the tens position will remain, and it's followed by a 0. Same thing with the 57. It rounds up to 60. All right, so something you can think of in looking at rounding. I'll make my little molehill here, if you will. And we'll say 1, 2, 3, and 4, 5, 6, 7, 8, and 9. All right. So if the number is 5 or larger, we round up. Round up means add 1 to your place value. Let me see if I can sneak that in to your place value. All right. And if it is less than 5, it stays the same. All right, so you leave your place value as is. So let's try a problem. Round 145 to the nearest 10. So let me write this number out for us first. 1, 4, and 5. The first thing you want to do is identify your place value. It says to the nearest 10. So we're looking for this 4. It either stays a 4 or it increases to a 5. What will help us determine it is to look to the right, right? And we ask ourselves, is this number larger than 5? Greater than or equal to? Let me write this all out so you'll have it for your notes. So is this number greater than or equal to 5? And our answer on this is going to be yes, it is, because it is a 5. It is equal to 5. So what happens here is we will add a 1. I'm going to do a plus 1 right below the number 4. And that will change this to a 1. 4 plus 1 is 5. Remember, anything after that rounded place value is a 0. So my final answer on here would be 150. And I would place 150 in this answer box. All right. Another way to think of this, for those of you that are visual learners, is to create a number line. And what I can do is put 140 to 150. Those are the nearest tens position, right? The tens place. So the number they gave us is right in the middle. This is my 145. So if it happens to be in the middle, remember we're going to round up. all right, because the number to the right of the place value is 5 or larger. If it were 144, then I would go to 140 as my rounded number. If it says 142, then I would round to 140. For this problem, it's asking us to round 42,441 to the nearest thousand. So nearest thousand, so the 2 is in the thousands position. And again, we want to know if this remains a 2 or if it increases to a 3. So we look to the right and ask ourselves, is 4 greater than or equal to 5? The answer is no. Since it is no, we're going to leave the 2 as is, follow that place value with zeros. So the answer for this would be 42,000. Again, you can use that number line if you like. When you're looking at the thousands position, we're looking at the original number would either round to 42,000 or it will round to 43,000. And this is 42,000. Remember, right in the middle here would be 42,500. So that means anything 42,500 or greater would go to the 43,000. And our value is 42,441. So I'm going to place a little dot and say that's my original number somewhere around there. It's probably a little bit off, but that's okay. So it's telling us we are going to round to 42,000 because it's closer to that number. All right, so we have several things to do on this slide. Complete the table by rounding the given number to the given place value. So they want us to take the original number and round it 3 different times, tens, hundreds, and thousands. So let me write this number down 3 times. And what I will do is I will underline the position that we want to round. So the first one said to the tens, and I'll just rewrite this over here so we have a note, tens, hundreds, and thousands. All right, so remember, we're going to take a look at each of these digits. We want to know, do they stay the same or do they increase? Once again, we have to look to the right of each of those values to help determine yes or no, do we round or do we not round? So in this case here, looking at the first option, 1,576, we have a 7 in the tens position. We have a 6 to the right. 6 is greater than 5. So this will round. That changes that 7. Remember, we're going to add a plus 1 to that 7. So this will round to 1,580. All right. The second option, rounding to the hundreds position. So we have a 5 in that hundreds position. We look to the right and it's the number 7. Is 7 greater than or equal to 5? And the answer is yes. So again, we will add a plus 1 to that place value. So now this creates 1,600 would be my rounded number. The last one is rounding to the thousands position. So we have the number 1 in that thousands position. The number to the right is 5 or greater. So that means we will add a plus 1 to that place value. So this number will round to 2,000. All right, and let me fill out our table then. So we have 1,580 for the tens position, 1,600 for the hundreds position, and 2,000 for the thousands position. This picture here is introducing you to the real number set. So all of the descriptions below fall under real numbers. So what I'll start with is, let's do with the smallest innermost circle, or ellipse I should say, is natural numbers. Natural numbers start with the number 1 and increase. So think about how you first learned how to count. We used our hands and we just count the number 1, first finger, second finger, and so forth. So 1, 2, 3, ... This means that it continues on and on and on. All right. Notice that the next circle enclosed around it is the whole numbers. The whole numbers include the natural numbers, but it also adds the 0. So 0, comma 1, comma 2, and ... Then we have the next circle is including the natural numbers and the whole numbers. So this is called integers. And the new part on here is it has the whole numbers. It includes the negative numbers. Numbers to the left of 0 or less than 0. Integers. All right, and all of those numbers, the natural numbers, the whole numbers, and the integers are also included in what is called the rational numbers. Rational numbers are values that you can rewrite as a fraction, but there's some conditions. We have the fraction. When you place it in your calculator or do some long division, you should come up with what's called a terminating decimal. So for instance, this decimal point 0.63, the decimal stops. In other words, when you do the long division, you'll get a 0 remainder. All right. The other option is when you have a repeating decimal and it's indicated with this little line or bar right across those numbers, like this number 12. That means the number 12 is repeated after that. So this would be decimal point 0, 12, 12, 12, 12, ... It goes on forever. All right. So for rational numbers, we have what's called a terminating decimal, a number that is in decimal form and it stops, or a repeating decimal with a bar over it. All right, so notice that left-hand side is rational. The right-hand side is irrational. All right, so think about rational versus irrational if you want to think about personalities, right? Rational would be something that can be defined easily to follow. Irrational is a little chaotic. So if you place the square root of 3 in a calculator, you will get a decimal value that goes on with no pattern, and it goes on and on and on and never ends. Pi is another one. If you were to look that up on that one, that is a number that never stops. We always use the 3.14, but there are a lot of numbers that follow that 4. No pattern, never ending. And this one here, notice this one has the ... on it. So again, it's never ending. So if you take the rational numbers and the irrational all together, you get the real number system. This is another image for your notes so that you can see the difference between rational and irrational, integers, whole numbers, and of course our natural numbers. Right, so it's asking us to list the numbers for the given set that are natural numbers, A, B is whole numbers, C is integers, D, rational numbers, E, irrational, F, real numbers. So they give us a number set, and notice that it's in braces, each value separated with commas. And they also give us a nice hint here. It says simplify, and that means square root of 36. So they want us to simplify the square root of 36. So the square root of 36 is equal to 6. All right, and again, it says use a comma to separate answers as needed. Do not simplify. So when it says do not simplify, although we did simplify that square root of 36, we're going to use the original setup of the number in our answer. So in this case here, the set of natural numbers, you're going to have my braces here, and we're going to look at our values and go from left to right and see if we have any numbers. Natural numbers start with the number 1 and higher. So there's no number that I can see that is 1 and higher except for the square root of 36, which simplifies to 6. Right, the next one's asking us for a whole number. Remember, look at the word whole, and that O should remind you that we start with 0 for whole numbers. 0, 1, 2, 3, 4, dot, dot, dot. So in this case, again, whole numbers include the natural numbers. We do have the number 0 here, and we have that square root of 36. So we're going to use that. 0, square root of 36. And I do not have any other numbers, and that will be my whole numbers. Integers. Now, integers, remember, include the natural numbers and the whole numbers, but it also includes the negative natural numbers, the negative natural numbers. So now we are including the -9 in our values. So I'm just going to rewrite this left to right here. Have a 0, we have the square root of 36 already included, and now we're going to add on our -9. All right, take a look at rational numbers. Remember, on the rational numbers are values that we can rewrite as a fraction, but that fraction, when we place it in our calculator, is a terminating decimal. In other words, it stops. Or we have a repeating decimal with a bar on it. So in this case here, I am going to add on the 3/10 or 0.3 right here because it stops. That's a terminating decimal. 3/4 is the same thing as 0.75. 0.75, it stops. All right. And we also have the 7 9/10 or 7.9. And that one also stops. So I'm going to include all of those with my rational numbers. So 0, 0.3, my square root of 36, -9, 3/4, and 7.9. So if you remember on that last slide, you are either rational or irrational. So any of the numbers that are not written down for the rational number set would be considered irrational. So the irrational is the square root of 5. If you place that in your calculator, you'll see that it's chaotic, never ending. There's no pattern. And also we know about that pi. So in this case here, we would have the square root of 5 and pi. And it left off f for us, all right, because the number f would actually be, for the letter f, excuse me, would actually be a list of all those values of the original set. So 0, 3/10, square root of 5, square root of 36, -9, 3/4, pi, and 7 9/10. So all of those numbers would make up the real numbers. Give an example of a whole number that is not a natural number. So I want you to think about that for a second. A whole number that is not a natural number. And then the question it asks, which of the following numbers below is a whole number that is not a natural number? So let's do a little review here. Change this to black. So we know our natural numbers start with the number 1 and go on. 1, 2, 3, and this ellipse, dot, 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 means it goes on forever. Right? The next set would be the whole numbers. Whole numbers include natural numbers, but it also starts with a what? 0. Remember I said to remember the O in the word whole to lead you to start with 0. It includes the natural numbers and it goes on and increases at that point. All right, so it says, give an example of a whole number that is not a natural number. And then it says, which of the numbers below is a whole number that is not a natural number? All right, so you can see just by looking that the 1, 2, 3, and so forth here is included in the whole number. The only item that is not a natural number is 0. So the answer to this question would be C, 0. I'll make that a big bold dot so you can see that. All right, so A, the number 5, the number 5 is a natural number and it is a whole number. All right, B is in decimal form and it's negative, so it's not even a natural number or a whole number. And again, also for D, it's a negative number, so therefore it is not a natural number or a whole number. So your answer on here would be C. Select the number that is an integer, a natural number, and a whole number. All right, so it has to satisfy all 3 types of number sets: integer, natural number, and whole number. So when we take a look at this first number, the square root of 2, if I were to place that in my calculator, I get something that looks like this: 1.4142113, and it just keeps going on from there with some crazy numbers. So that's considered an irrational number. Now, if I place the number 1/9 in my calculator, I get a 0 with a 1 and a bar over this because it's repeating ones. So again, repeating decimals, that's going to be rational, a rational number. 0.5, that's a terminating decimal, so that is also a rational number. So we hope that this final answer, D, would be our final, or the correct answer, I should say, for this problem. So the number 5 is a natural number. Remember, we start with the number 1, 2, 3, ... So it's included in the natural number. And if it's a natural number, it is also included as a whole number. And if it is a whole number, it is also included in the integer. So the number 5 would be your answer. Before we move on to simplifying expressions, we need to review order of operations. So let me write this out. Order of operation is just that. It is a specific order that you need to follow in order to simplify expressions correctly. Order of operation. All right, so some people remember this as "please excuse my dear Aunt Sally" or PEMDAS, however you'd like to see it. But the first step on here is to identify your grouping symbols. Right, so for your grouping symbols, we start out with parentheses, if you will. All right, so the grouping symbols, it can be parentheses. I'll just put a set of parentheses here. It can also be brackets. That's a grouping symbol. It could be braces, such as those number sets we just finished looking at. We can have a fraction bar. And we can also have absolute value bars. Let me just sneak this in here. The absolute value has 2 vertical bars on there. And it'll have some value listed on the inside of it. All right, step 2, after you've identified your grouping symbols, inside your grouping symbols, you're always going to go left to right. We're going to look at exponents. So an example of an exponent, for instance, I can say 2 to the 3rd power. if this were in my expression, I need to simplify that. So that is 2 times 2 times 2, which simplifies to 8. So instead of leaving it as 2 to the third, I would rewrite with just the number 8. Third step, multiply or divide. From left to right. All right. So when you take a look at your expression from left to right, it can be a multiply sign or a divide sign. It doesn't matter. Whichever one occurs first is the one you have to do. So this would be our times symbol here. Sometimes it's a solid dot. Sometimes they use an asterisk to represent the multiplication symbol. Divide, you'll see the division here, or you may have it listed as a fraction. All right, left to right. So multiply or divide from left to right, whichever occurs first. Step 4 is add or subtract. Again, from left to right. So the add would be a plus sign. Remember, it's a big or right here. And then the subtraction sign. All right, so when I said that people remember PEMDAS, this is what they remember. First thing you want to look at is your parentheses. And inside the parentheses, you next look at your exponents. You multiply or divide. Remember, this is the or. And lastly, you add or subtract, left to right. So PEMDAS, please excuse my dear Aunt Sally. Now that we have reviewed order of operations, let's look at our first problem. It says simplify 28 divided by 7 times 4 plus 9. All right, so the first thing I'm going to take a look at on this expression is it's called an expression because it is made up of numbers and operating symbols. It does not have an equal sign. So therefore, this is called an algebraic expression or just an expression. All right, so simplifying means perform your order of operations. So I'm looking for parentheses. Looking left to right on my expression, I do not see any parentheses. Then I'm going to look for exponents. Do I see any exponents? Well, no, I do not see any exponents. All right, so that was step 1 and step 2. Step 3 is multiply or divide from left to right. So I'm going to put a little arrow right here. Multiply or divide from left to right. Now, although I have a division and a multiplication symbol, I have to do what occurs first. So this division symbol occurs first. So I need to take 28 divided by 7, which gives me 4 times 4, and I'm rewriting the rest of my expression. All right, so if you remember, I said adding and subtracting is last. So that means I need to do a repeat again of this multiply and divide one more time. So that I can complete all my multiplication. So 4 times 4 will give me 16, and then my plus 9 follows. All right, lastly, I'll do add or subtract from left to right. Again, it does not matter since we don't have but 2 numbers to add. And once I add those together, I will get 25. So this would be my final answer that I will insert onto the program. I'm going to select option A here and place number 25 in that box. Let's try this next problem. 6 to the second power times parentheses 6 minus 4 close parentheses plus 3 to the third power plus 4 to the second power. Remember, the first thing you're going to look at is your PEMDAS, so parentheses. So we're going to go and clear what's inside the parentheses and rewrite everything else from left to right. So it still remains as 6 to the second power or 6 squared. In parentheses, 6 minus 4 now becomes a 2. And rewrite the rest of the expression. All right, the next step we're going to take a look after we've handled our parentheses, we've narrowed it down to one number, we're going to go look at our exponents. So all of these exponents here, the 6 to the second power, this means 6 times 6. The 3 to the third power means 3 times 3 times 3. And 4 squared, or 4 to the second power, is just 4 times 4. So once we rewrite after taking care of our exponents, we have 36 times, and then there's step 2. You can drop the parentheses off if you'd like. 3 to the third power is 27, and 4 to the second power is 16. So we took care of our exponents. Your next step is to multiply or divide from left to right. So we do have this multiplication to take care of, this 36 times 2. When we multiply that, we will get 72 plus 27 plus 16. Lastly, we do our adding and subtracting from left to right. And I'm just going to add these first two together. Again, you can do all of it at one time if you want to line it up vertically and do your addition that way. So this will give you 99 plus 16. And then when you repeat the adding and subtracting from left to right, that step, you should get 115 as your final answer. Let me write this little repeat here so you know to repeat the add and subtract is what I did. So once again, I will select answer A as the correct answer and place my number or value that I came up with, 115, in that box. To simplify the next problem, we need to take it by parts. Remember, part of the grouping symbol besides parentheses would be that fraction bar. So what happens is you have the numerator, fraction bar, you have a numerator, fraction bar over the denominator. A fraction bar separates the top from the bottom. So you simplify, you do order of operations in the numerator, you do order of operations in the denominator, and then you can place them together. So you can do them separately and then come back together on the end, or you can do it all at one time if you do not get confused. So what I will do is I'm going to see if I can rewrite from left to right here. So parentheses first. So I'm looking at 7 minus 2 in the numerator. So this is going to be 7 parentheses, and 7 minus 2 is 5. And I'm just rewriting the numerator from left to right. I just took care of P for PEMDAS, right? The parentheses. Next, I look for exponents on that numerator, and I do not have any exponents. And the next thing is multiply or divide. So I will do the multiplication right here, which will give me 5 times 7, or 7 times 5 will give me my 35. Rewrite from left to right, plus 5. And then add and subtract last, and that will give me 40. So there's my numerator simplified. Then I'll take a look at my denominator. Denominator does not have any parentheses or grouping symbols, but it does have an exponent. So I'm going to take care of this 2. So this is 5 times 5 for that 5 squared. So 5 times 5 makes that 25. Rewrite my subtract 5. And 25 minus 5 is 20. And I'll just carry it over to that final fraction. 40 divided by 20 is equal to 2. So 2 would be my simplified answer. Again, I'll select choice A as my answer and fill it in with the number 2. Let's simplify this next one. So once again, I'm going to separate the numerator from the denominator. I'll focus on the numerator at first, and I'm looking for parentheses or grouping symbols, and I do not have any. The next thing I'm going to take a look is exponents. So this 8 to the second power is going to give you 8 times 8. All right, and that's from this 8 to the second power. So if I rewrite that, 8 times 8 is 64. So I have 2 plus 64 in the numerator. There's nothing else but adding now, so I will add those together and I will get 66. So my numerator is simplified. Let's take a look at the denominator. Now the denominator, I do have parentheses that I can take care of, this 23 minus 19. And I do not see any other sets of parentheses or grouping symbols. So 23 minus 19 will give me 4. So I will rewrite that. That's 5 times 4. When you have a number in front of parentheses or brackets, that is implying multiplication. And I will rewrite everything else. All right, so that was your parentheses. Remember, we're going in the order of PEMDAS. Next, I'm looking at exponents in my denominator. So that is at 3 to the second power, or 3 times 3. And that will give me 5 times 4 minus 3 times 3, which is 9, minus 8. All right, so I took care of exponents. Next is to take care of multiply or divide from left to right. So I'm going to do this 5 times the 4. And I will just bring my numerator over, 66. All right, 5 times 4 is 20. And I have 20 minus the 9 minus the 8. And then from here, again, I'm going to rewrite my numerator. And I'll go left to right, add or subtracting left to right. So 20 minus 9 is 11, minus 8. Rewriting once again, adding and subtracting from left to right will give you 66 divided by 3. And my final simplified answer is coming out to be 22. 66 divided by 3. And I know this looks like a lot, but I am showing every step so that you understand how I am applying order of operations. Right, so selecting answer A and putting my answer 22 in. For our last problem, let's see if we can perform the order of operations or simplifying the expression. So in this case here, you can see that we do not have any grouping symbols, so we do not have to worry about parentheses. The next thing you want to take a look at are the exponents, and we do have an exponent with this 2 times 2, or 2 to the second power. So this leaves me 6 divided by 3 plus 4 times 2 minus 9. And at this point here, the next thing is to look at multiply or divide from left to right. So I have a 6 divided by 3 that I will take care of first, and then followed by the 4 times 2. 6 divided by 3 is 2. There's my plus sign. 4 times 2 is 8. And bring down the subtract 9. Our next step is to add or subtract from left to right. So I will take the 2 plus the 8, gives me 10. And bring down the minus 9. Again, we'll repeat the adding and subtracting once again, left to right. And 10 minus 9 is 1. And so again, I choose option A, insert my answer as 1. So this is how you perform order of operations in simplifying expressions.